Hi everyone! In this video, we'll learn how to use the TI-84 calculator to find binomial probabilities. We'll focus on choosing the correct calculator command and interpreting probability statements such as exactly, at most, at least, and greater than. Let's begin. Let's begin by looking at this table. This table summarizes the most common probability statements and the TI-84 commands used to calculate them. The two commands we'll use are binompdf and binomcdf. They are different. A good place to start is with the word exactly. If the probability statement asks for exactly X successes, use binompdf of npx. The command binompdf calculates the probability of one specific value. So it is only used when the probability statement contains an equal sign. For all other probability statements, we'll use binomcdf. The command binomcdf calculates cumulative probabilities, meaning it adds probabilities over a range of values. Now, let's look at the remaining probability statements. If the wording says less than or equal to, use binomcdf. For less than or equal to, use binomcdf of npx. For less than, use binomcdf of npx minus 1. If the wording says greater than or equal to, we'll use the complement rule. The complement rule is 1 minus binomcdf. For greater than or equal to, use 1 minus binomcdf of npx minus 1. For greater than, use 1 minus binomcdf of npx. Here's a simple way to remember these commands. Exactly, use binompdf. Less than or equal to, use binomcdf. Greater than or equal to, use 1 minus binomcdf. The most important skill is translating the wording of a probability statement into the correct calculator command. We'll practice that skill in the examples that follow. Let's look at example 2. A fair coin is flipped 12 times. Let X be the number of tails. This means we are interested in counting the number of tails, so success is the number of tails. Find the probability that X is greater than 7. Round to 4 decimal places. First, let's identify the values. N is the number of trials. Since we flipped the coin 12 times, so N is 12. P is the probability of success, and success is the number of tails. So P is the probability of getting tail on each flip. Since the coin is fair, so the probability of getting tail is 50%, which is 0.5. We're looking for probability that X is greater than 7. That matches this one. Probability that X is greater than a number. In this case, this number is 7. We use this command. 1 minus binomcdf of npx. N is 12. P is 0.5. And X is 7. And we are going to put this in our calculator. On the calculator screen, enter 1 minus. Next, press second vars to open the distribution menu. Scroll down and choose binomcdf, then press enter. The calculator will ask for the trials, p, and x value. Trials is your n, which is 12. P is 0.5, and x value is 7. Highlight paste and press enter. You should see this command on your home screen. Before pressing enter, make sure the command matches the probability statement you wrote on paper. Then press enter. The calculator returns this, and this is your answer. The question is asking to round to 4 decimal places, so the answer is 0.1938. So, the probability of getting more than 7 tails in 12 flips is 0.1938, or 19.38%. Now, let's look at example 3. A test consists of 10 true-false questions. To pass the test, a student must answer at least 7 questions correctly. If a student guesses on each question, what is the probability that the student will fail the test? Let's identify the values. There are 10 questions, so n equals 10. Because the question is true or false, the probability of getting a question correct by guessing is 50%. So p equals 0.5. Now, let's determine what probability we're looking for. A student passes the test by getting at least 7 questions correct. That means the student fails by getting fewer than 7 correct. So we want to find the probability that the student will fail the test. That means we want to find the probability that x is less than 7. Now, let's look at our calculator table. We want to find the probability that x is less than a number. In this case, the number is 7. We use this command, binomcdf of n, p, x minus 1. N is 10, p is 0.5, x is this number. And 7 minus 1 is 6. So we have binomcdf of 10, 0.5, 6. And we are going to put this in our calculator. First, we want to open the distribution menu by pressing second vars. Then scroll down to find binomcdf and press enter. Trials is 10, p is 0.5, and x is 6. Highlight paste and press enter. Now, you should see this command on the screen. Before pressing enter, make sure the command matches the probability statement you wrote on paper. Then press enter. The answer is 0.828125. And the question is asking for 4 decimal places, So it's going to be 0.8281. P of x is less than 7 equals 0.8281. What does that mean? X is less than 7 means the student gets fewer than 7 questions correct. Since a student must answer at least 7 questions correctly to pass the test, getting fewer than 7 correct means the student fails. Therefore, the probability that the student will fail the test by guessing on every question is about 0.8281 or 82.81%.